In this video, we've got 3 different example problems where we're going to be multiplying radical expressions. So in this first example, we've got 4 times the square root of 5 times 3 times the square root of 8. And what you do is just multiply any number in front of the radical by any other number in front of a radical. So we're going to do 4 times the 3, and that's going to give us 12. And then you multiply anything that is under the radical by anything else that's under the radical. So 5 is under the radical, 8 is under the radical, so you're going to do 5 times 8, and that gives us, that should be in black. That's going to give us the square root of 40. Okay, and now it's just a matter of simplifying things. So we've got 12 written again. Now, is there any perfect square that divides into 40? There is. It's going to be 4. So I write square root of 4 times the square root of 10, because 4 times 10 gives us 40. 12 times the square root of 4 is 2, and then times the square root of 10. 12 times 2 is 24, times the square root of 10, and that's going to be our final answer. So you just got to be careful to make sure you multiply the correct things by what they need to be multiplied by. Now this example is just a little bit more complicated than the last one, just because it has some more terms under the radical, but you treat it the same way. So we've got a 2 times 3, so let's multiply those together. That's going to give us a 6. Now we multiply everything that's under the radicals. We've got a 7 times 6, that gives us 42, and then x cubed times x to the 7th, that's going to give us x to the 10th. Okay, whenever we multiply variables, we add their exponents. And then y to the 1st times y to the 13th, that's going to give us y to the 14th. And remember, we're taking the square root of all that. Okay, now we just got to break down everything. So 6 times, is there any perfect squares that go in 42? And no, there isn't, so we just keep on going. I'm going to write 42, taking the square root of that. And now 6 divided by 2, does that work? Does 2 divide evenly into 10? And that is true, so we'll have x 10 to the 2nd power. I'm just moving that into exponential form. And then is 14 divided by 2? Yeah, so I can move that into exponential form as well. That's going to be 14 divided by 2. Simplify a little bit more. We've got 6 times the square root of 42. We said we can't break that down. And then x to the 10 divided by 2, that's going to be x to the 5th. Now we need to include absolute value because we have a odd exponent, and that came from an even exponent. So that's when we apply the absolute value bars. Now we've got y to the 14 divided by 2, that's going to be 7. And then that has to be in absolute value bars as well, because that's an odd exponent, and that came from an even exponent up there. So that's more or less your final answer. I'm going to rewrite things so that it looks like more of standard form. I've got 6 times the absolute value of x to the 5th times the absolute value of y to the 7th, and that we're taking the square root of 42 still, so we could write that at the end. And this is going to be our final answer right here. In this last example, we have 2 binomials being multiplied by each other. They have radical terms in them as well, and although they look different, we still treat them like x minus 3 and times x plus 4. So like something like this, we know to distribute it out and make sure we multiply all the terms by, what we're supposed to be multiplying them by. Do the same thing with this stuff. So we're going to start off with doing 2 times 8, which is 16, and then 2 times the square root of 4, that's going to be plus 2 times the square root of 4. And then we come back down through here, we do negative 5 square root of 3 times 8, and that's going to be minus 5 times 8, that's 40, and then times the square root of 3. Okay, remember, never multiply like a number by itself by whatever is underneath it. Like, don't do 8 times 3 to give you 24. Just multiply it by the number that's out in front. Okay, so negative 5 times the square root of 3 times square root of 4, that's going to be minus 5 times 3 and 4 multiplied by each other is going to be 12. So that's going to be the square root of 12. And now we have to ask ourselves, can any of these be combined? Well, 16 is by itself, so I'm just going to rewrite that again. That's going to be 16 out in front. Now, all these have radicals, but they're all different. So if they're all different, we always make sure that they're all simplified. Well, 4, we could actually break that down. Well, we could actually take the square root of 4. So that's going to be plus 2 times the square root of 4. That's going to be 2. So I'll write that like that. And then we've got minus 40 times the square root of 3. And I wrote that again because square root of 3 can't be broken down at all. There's no perfect square that divides into 3. Now we've got minus 5 times the perfect square of 4 goes into 12. So I'm going to break that up into 2 different radicals. 4 times 3 gives us 12. And this might work, this may not work, but we'll try it out. So now 16 plus, we'll make this 4, right? 2 times 2 is, whoops, 2 times 2 is 4. And then again, we've got minus 40 times the square root of 3. And then minus 5, this is going to be times 2 because the square root of 4 is 2 times the square root of 3. Alright, simplify a little bit more. So we've got 16 plus 4, that's going to be 20, minus 40 times the square root of 3, minus, and then 5 times 2 is 10, minus this, or well, minus 10 times the square root of 3. Now we've got 2 different parts that have the same radical. So 3 and 3, those are the same radicands, so we could actually combine these 2 parts. So this 20 is stuck by itself, we write that again, and then negative 40 minus 10 is going to be a negative 50. And then we could include that square root of 3 at the end, and that's going to be our final answer. So let me go over all this again just to make sure it all makes sense. Distribute everything out so we get these 4 terms. Then taking the square root of 4, that's going to be 2. Can't do anything here. 12 could be broken down into 4 and 3. And then when we simplify a little bit more, combine like terms, we've got 16 plus 2 times 2 is the 4. We brought that down. Square root of 4 is 2. And then we eventually multiply the 5 and the 2 together to give us this part right here. We bring down this, bring down these 2 and we combine them, and then these 2 terms right here can be combinable, and that gives us 20 minus 50 times the square root of 3. The only thing that I advise is to just be really careful when you multiply all this stuff out up here. That can be kind of tricky sometimes.